Lesson 9, Divide Decimals. We'll go over keywords, review whole number division, partial quotients with decimals, the grid model for division, using word form for decimals, the standard algorithm with decimals, and go over a couple things to remember. Here are some division keywords. They all pretty much have the same idea. We're splitting something up, whether it be food or even people, separating people. We do that with classes. We can do that whenever it's division. It simply means they all have equal or the same size of the group. That's the big thing that separates division from other things. It's equal groups. We are looking for equal size groups, equal size pieces. So here we have some whole numbers. So we're just going to review how to use the whole number strategies. So here I have 164 divided by 4. I'm going to set up a chart. And that'll help me know how many groups of 4 could be inside 164. So here I'm multiplying by 4 and a couple other numbers. I'm just setting up my chart. And I always like to start my chart off with 1, 2, and 3, just for safety. Because really, I know those. I know what 4 times 1, 4 times 2, and 4 times 3 is. And if I need to add more, I can always add on after that. So I have 4 times 1 is 4. Let's just switch colors. Let's use blue. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. As you can see, 12 is nowhere near 164. So we're going to have to keep going. So I'm going to add on to my chart. This time I'm going to use 10, 20, and 30. And just for safety, I'm going to put in 100 just to see how big I can go. And when I can stop. So let's do this. 4 times 1 was 4, and I just bring the 0 in. 4 times 2 was 8, so I just bring my 0 in. 4 times 3 was 12, and again, bring that 0 in. 120 is very close to my target number. Let's check 4 times 100 just to be sure. 4 times 100 will be 400. That's way too big. So my first clue about what my answer should look like, I should be somewhere near 30. Something near 30 is my final answer, something near that. So right now, let me take out 30 groups of 4, and every time I do that, I'm going to subtract. Take out the 120. And that leaves me with 4 and a 4. And I'm going to put my 30 groups of 4 over on the side. 30. Okay? So how many groups of 4 are in 44? Well, which one of my numbers down here is close to 44? 40. 40 is perfect. 40. How many groups of 4 was that? 10 groups. So put a 10 over here and subtract. How many groups of 4 are in 4? Just 1, as you can see right here on our chart. So here are all my partial quotients, and my total is 41. So 30 was definitely my best estimate using the chart. It wasn't 100 and it wasn't 20. 30 was my best estimate. 30 and 41 are pretty close. So let's move on to our decimal division. So we're going to use the same idea as before. let's just set up our problem. We have 1 and 56 hundredths divided by 12. Well, for right now, we're going to pretend like the decimal does not exist. So we're going to set up our problem, 156 divided by 12. Okay. So remember, this is 156 hundredths. That last name is still there. We're just not saying it right now. Again, I'm going to set up my chart. And we can see if that's enough. Alright, I'm going to start off with my 12 times 1, 2, and 3. Oops, come on, there we go. 12 times 1 is 12. 12 times 2, well, that's 12 plus 12, which should be 24. 12 plus 24, 36. Nowhere near 156. We're just not there yet. So we're going to bump it up with the power of 10. We're going to do 12 times 10, 20, and 30, and see what we have. Here we go. 12 times 10 would be 120. 12 times 20 will be 240. Oops, look at my number. 240 is way too big. So we're going to stop there. We don't need to make a chart longer than that when we already figured out. We have a pretty good estimate already. We know that our number, our final answer is going to be somewhere near 10. So let's begin. Let's take out 120, and that is 10 groups of 12, and subtract. 6 minus 0 is 6, 5 minus 2 is 3, and 1 minus 1 is 0. Well, I'm left with 36. Do you see 36 on the chart? It's right there. Perfect. 36 is right there. So we have 3 groups of 12 and 36. And that leaves us with 0. And our quotient will be 13. But wait. Remember, this is a division with decimals problem, so we're not quite done yet. Remember, we ignored that decimal like it just wasn't there? Well, it's still there. The original last name of this number was 156 hundredths. See that? It's right there, hundredths. The 6 is in the hundredths place. So the whole thing is called 156 hundredths. But because we divided by a whole number, our answer is going to say the same last name as before. So 156 hundredths divided by 12 has to be 13 hundredths. And how do I write that as a number? Well, I need to make sure that that 13 lands in the hundredths place. So I'm going to draw my decimal point and the 2 place values that I need. This one's the tenths place. This one's the hundredths place. Let's put that. Where would the 13 sit? Well, the 3 has to sit in the hundredths place, and the 1 sits right next door to it. This is your answer. So when we were working on division back in lesson 6, it's going to be used again in lesson 9. The only thing that will be different is these last names and how we use them. So we use the same strategy that we had from lesson 6, and we applied them to decimals. Okay, so the answer is 13 hundredths. Here's another strategy you might like to use. And there's grid paper in the classroom if you're wondering. We can use grids to divide. So the first thing I see in my dividend is 2 1/10, also known as 21 tenths. You can just say the number like it's a whole number and then say the last name of the decimal point. So that is another strategy you can use. 21 tenths divided by 3 wholes, divided by 3. So I'm going to always draw what I have. Always draw your dividend, because that's what you own right now. So I'm going to draw 21 tenths as best as I can. And in every single grid, unless otherwise stated, there should be 10 tenths in every grid. So every single one of them has 10 of them in there. So I'm just going to count. This is black. I don't want to use that color. So in this grid, let me use something easier. Let's use something easier. Cool. So we're going to count to 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't want to count like that again. I know that each grid has 10. I've already colored in 10. I need 11 more. So I'm going to color in this whole grid, because that's going to give me 10 more. And then I just need 1 more tenth. In total, there should be 10. There should be 10 right here, 10 in this picture, and 1 in this picture. 21 tenths. Now we're going to divide them into groups of 3. Let's use purple. So the groups of 3. 1, 2, 3. 1, 2, 3. Oops. I'm all out of. Go straight. 1, 2, 3. Okay. So you see how I have a little piece left over here? I'm going to clump it together with the next 2. 1, 2, 3. 1, 2, 3. 1, 2, 3. And I have 2 pieces left over. I'm going to clump it into a nice group with the next one. 1, 2, 3. And we are done counting by 3s. So how many groups of 3 did I make? Let's count the lines. The lines tell you how many groups you've made. 1, 2, 3, 4, 5, 6, 7. 21 tenths divided into 3 groups is going to give you 7. Except look at that last name again. 21 tenths divided by 3 is actually going to be 7 tenths. How do I write that as a decimal? Write your decimal point and find the place value that the word is telling you to go to. 7 tenths. 7 tenths. So when it really talking about is 21 tenths divided by 3. So this one goes in a group. So I'm going to actually just use my colors to better illustrate that. So all the yellows will stay together, all the red groups. We're going to count up all the red groups in a moment. and then all the blue groups will stick together. So if this was a word problem, it could be a money problem. It's like someone has 21 dimes, and they're giving it to their 3 friends, but they want to give each friend an equal amount. So I'm going over with blue just to show you how each friend is going to get 7/10. So if we count the yellow ones, so let's count the blue ones. That's easier to see. When you count the blue ones, how many tenths do we give to that person? How many dimes do we give to that person? 1, 2, 3, 4, 5, 6, 7. So 21 tenths divided equally by 3 is 7 tenths. Written this way in word form, in number form, I'm sorry. So here's that word form again. I'm going to call this number, my dividend, 12. And what's that last name? The very last place value that we're using? 12 tenths. Okay. And I'm going to divide it by 5 hundredths. Uh, 5 hundredths. There's a problem here. If the words or the last names are different, we've learned this before, if the last names are different, you need to change one of them. You have to change it to the smallest place value. So hundredths is smaller than tenths. Sounds bigger, but it's actually smaller. So we're going to change 12 tenths, and we're actually going to call it 120. Okay, that's what it is. We're just putting a 0 at the end. We're not changing the value, just changing the way we say it. So this is 120 hundredths. Oops. Now that they have the same last name, we can ignore the last names like they're not there and just do division like we want to. So now that they have the same last names, we can begin. Hundredths, hundredths. So let's start. Let me erase. Okay, so we figured out that 1 and 2 tenths is also called 120 hundredths, and 5 hundredths is going to go out here. So we're just going to ignore that decimal like it's not there because they have the same last name. We don't need to work with that anymore. When they have the same last name, you can actually just get rid of the decimal. We're really asking how many groups of 5 are in 120? How many groups of 5 hundredths are in 120 hundredths? It's the same thing. So let's begin. Set up my chart. Yeah, 5 times 1, 2, 3. And I know that my number's in the hundreds, so I'm definitely going to need to get a little bigger. So 10, 20, 30. We'll stop there. 5 times 1 is 5. Let's make that look like a 5. 5 times 2 is 10. And 5 times 3, well, that's 5 more, so 15. See, we're nowhere near 120. We need to get a little bit bigger. 5 times 10 is 50. 5 times 20 is 100. And 5 times 30 is 150. Red alert, that number is too big. so we cannot use it. Our best estimate is something near 20. So which is the best one to use? Of course, it's going to be 100. That's our very nicest number to use. Nope, nope, nope. Okay, and remember to put your groups on the side. Don't forget. So 20 groups of 5 is 100. So we're going to take that away. How many 5s are in 20? Looking at my chart, I can see 15 is very close. And that's 3 groups of 5. And that gives me 5. How many groups of 5 are in 5? 1. So what is my total quotient? My total quotient is 24. Because my decimals have the same last name, I did 120 hundredths and 5 hundredths, my quotient does not need to have that same last name. How many groups of 5 hundredths are in 120 hundredths? 24 of them. There are 24 of them. So using the word form can be really helpful when the decimals have different last names. It just helps us think about what we're actually going to do. Things to remember. When dividing by a whole number, whatever last name was used for the dividend, you're going to have to use it again. So this was 24 tenths. Divided by 6 wholes equals, well, 24 divided by 6 is 4. So that last name has to come back. So it's actually 4 tenths. And in word form, you're going to change it into decimal form. So you have to put that 4 in the tenths place. When dividing tenths by tenths, you can actually, when you see them written out, 15 tenths, divided by 5 tenths. They're asking you how many groups of 5 tenths are in 15 tenths. Well, actually, that's just going to be 3. You do not need to rewrite the last name. There's going to be 3 groups of this. If I said 3 tenths, it wouldn't really make sense. 3 tenths groups of 5 tenths equals 15 tenths. That doesn't really make much sense. But 3 groups of 5 tenths, we'll draw that, and you'll see that you'll get 15 tenths. You'll get 15 of those blocks. So the answer is just 3. And finally, here we have a problem where you see that this is ending in the tenths place, and this is not. This is ending in the hundredths place. So when you're dividing hundredths by hundredths, make sure you make it look that way. So it's not going to be 1 and 2 tenths anymore. It's going to be 1 and 20 hundredths. We have to hit that hundredths place. So when they say the last name again, make sure they're the same last name. 120 hundredths divided by 4 hundredths. And then you can just work like that. You can just move. You can actually forget about the decimal after that. Once they have the same last name, it becomes a lot easier to work with. So make sure you do that. So whenever you write this. It now is 120 divided by 4, which is 30. So make sure they have the same last name. If they don't, you can change it. Put a 0 on it so that it has hundredths. So when you're dividing by a whole number, you need to rewrite the last name at the end. Don't forget it. When you're dividing tenths by tenths, you don't need a last name anymore. It's done. And if you're dividing hundredths by hundredths, once they have the same last name, you can forget about the decimal. You don't need the word to come back. You're done. So this is from the first page of the homework, in case you get stuck. So they want you to think about 5 and 4/10 divided by 6. So they really want you to think about how division and multiplication are related. The beginning of a division problem is the answer to the multiplication problem. And the factor from the, well, not the factor, the divisor from the division problem is the factor in the multiplication problem. So think about it like this. Instead of 5 and 4/10 divided by 6, it's 6 times something gives you 5 and 4/10. Okay? So also think about that 5 and 4/10 is also called 54/10. So now it's 6 times something equals 54. If you know your 6 times tables, you already know the answer. 6 times something gives me 54/10. Once you figure out what goes in this line right here, 6 times something, check your multiplication chart, you'll know what goes in here. It's the same number. It's the exact same number. But you're going to write it in tenths because it's the tenths. So make sure that you write it as a decimal. Number 4, Connor earns $9 an hour for yard work. Okay. He raked leaves one afternoon and earned $29.25. How many hours did he rake leaves? So we know the answer of how much money he made. We want to figure out, how did he make that much money? How long was he working to make that much money? How did he get to $29.25? Well, set up the division problem. It's 29 and 25 divided by 9. So how many hours did it take for him to earn the $29.25? For this particular problem, I suggest taking out the decimal like it doesn't exist, doing your division, and then remember to put the decimal back in. If it started with the hundreds place, you have to put it back in. Don't forget that. So do the division like you know. Set up your chart and figure out how many hours he must have been working to earn $29.25. We're going to take the decimal out for a moment, and you're going to put it back in when you get your final quotient. Number 6, the Roslin family drinks 5/10 gallon of milk a day. Will 2 5/10 gallons of milk last them more than 1 week? Well, let's do cubes for this. Circle all the numbers that we're going to use. Okay, so I see 5/10 and 2 5/10. Underline the question. Will 2 5/10 gallons of milk last them more than a week? Box the math action words. A day lets me know that it's something that's repeatedly happening. And we know that repeated addition or repeated subtraction have other names as well. So we know that we're going to be working with either multiplication or division. We need to set up our equation and then solve. So first of all, if they drink 5/10 of a gallon of milk every day, how much will they need for an entire week? Well, there are 7 days in a week. So that's one of those numbers that kind of almost tricked us. 7 days. How much will they need for 7 days? Figure that out and you'll know. Do they have enough? Will 2 5/10 last 7 days? Here we have a problem where we're dividing hundredths by hundredths. So we have 1 2 hundredths divided by 6 hundredths. We can also just call it 102 hundredths. Take the decimal out. 6 hundredths. Now we can just divide like normal. 102 divided by 6. Set up your chart and you'll be good to go. Whatever answer you put on this line is the same answer for this line. They're just telling you, they're just trying to show you that when they have the same last name, you can act like it's a whole number, and that's the answer. So when you find the answer to this problem, put it on that line. Okay. Number 6. Ray feeds his dog 1/1200 kilogram of dry dog food each day. He wants to buy the smallest bag that has enough food to feed his dog for 1 month. Should he buy the bag that has 1 8/10 kilograms, 2 4/10 kilograms, or 4 2/10 kilograms of dog food? All right, circle those important numbers. So he feeds his dog every day. And he wants to know how much he wants to feed him for an entire month. The box of math action words each okay, so the each is a division word. Should he buy the bag that has 1 8/10, 2 4/10, or 4 2/10? Well, what's the place value that we're working with right now? What place value do we say for this number? It's called 1/1200. So that means all my other numbers need to have hundredths. So what I'm going to do, I'm going to rewrite them all with their hundredths. So this is 180 hundredths, 240 hundredths, and this is going to be 420 hundredths. We need to figure out what's the smallest amount he can buy to feed his dog for one entire month. Well, let's figure out what a month is. How many days are in 1 month? Some months have 28 days, some months have 30 days, and some months have 31 days. Let's use 30, just because I like that number, and it's easy to work with. So we need enough dog food for 30 days. So we have 12 hundredths being eaten every single day for 30 days. Which one of these dog food bags would be the best one to buy? Remember, if it doesn't last for 30 days, the dog won't have anything to eat. So we need to make the best decision. There are multiple ways you can deal with this. You can either use multiplication or division. Either way, you should be able to figure out which one of these bags is the best one to buy. In Lesson 9, we talked about dividing decimals. We went over keywords, reviewed whole number division, used partial quotient division for decimals. We used the grid model for division. We used word form for decimals. We saw a little bit of the standard algorithm with decimals. And we talked about things to remember. I also went over some of the questions that I thought were pretty difficult. Hopefully it was helpful to you. That's it for Lesson 9.